Section 8.5 is equations in Cartesian coordinate system. And we're going to start out with talking about reminding you what the Cartesian coordinate system is. So this is an image of the Cartesian coordinate system. You'll notice that quadrant 1 is in the top right-hand corner, and it goes counterclockwise around. Does anybody know why? Have you heard before? When they were labeled by someone who was left-handed. That's actually why, for reals. So that's kind of a cool fact. The right-hand side of the graph are positive x values. The left-hand side of the graph are negative x values. The top of the graph are positive y values, and the bottom of the graph are negative y values. An ordered pair is always written with the x value first and the y value second. So this is an x value of 4 and a y value of 3. The point in the middle is called the origin, has ordered pair 0, 0. And yeah, I think that's about all we need to talk about from the picture point of view, and we're going to fill in a few details about it. All right, so a point is a location in the coordinate system given by the ordered pair of numbers AB. The x-coordinate is also called the abscissa. I don't think that's right, but I don't remember how to pronounce it. It's called the first coordinate. And then we've got our ordinate, which is our y-coordinate, our second coordinate. And a graph is the resulting picture if we plot the points that are given for a given, or plot the points that satisfy a given condition. So you sometimes end up with lines, sometimes you end up with curves, sometimes you end up just with particular points on a graph. It doesn't have to be connected. It depends on the situation that you're looking at. There are two very special lines that we're going to talk about first. Those are vertical lines and horizontal lines. So a vertical line is the graph of an equation that starts out x equals, and then it's a number. So x equals 5, x equals 8, x equals negative 362, whatever, okay? X equals a number. And that's a vertical line, okay? Straight up and down vertical. All points on the blue line, our vertical line here, have coordinates 2b, right? Every x coordinate is 2, and every y coordinate is something else. I mean, it could be a 2, but it doesn't have to be, okay? And b is a real number. So we would say that the line right here is the line x equals 2. And the reason is because every x value along that line is 2. Okay? Horizontal lines is like the horizon where the sun sets. Okay, horizon. Horizontal line looks like straight across. I know we like to use the word straight with lines, which is just so funny. We do it all the time. I do it too sometimes because lines are by definition straight, but we do this. Sometimes people will use straight to mean horizontal as well, which is not at all ambiguous, of course. But horizontal means flat, okay? So it has an equation y equals a constant. And all points on this blue line will have coordinates a3. So the second coordinate, the y value, is constant. It's the same for every single point that I would plot along that blue line. And so this line has the equation y equals 3, because every point along that line is a y value of 3. All right, so before you flip this page, I want to give you an acronym. Has anybody seen this acronym before? HOIVEX. Nope. Cool, then I get to show you something new. All right, so we're talking about horizontal and vertical lines, so what do you think the H and the V are in this acronym? They are. They're horizontal and vertical. So this is horizontal, and this one's vertical. All right, the O is actually the number 0. So let's start with the HOI part, H-O-Y. Horizontal lines have 0 slope. And their equations are y equals a number. Okay, 0 slope, it's flat. If I calculated rise over run and so forth, we're talking more about that later, I would get 0. Vertical lines have, do you know what the U is? Undefined slope. So how does that happen? Well, when I calculate slope, it means I get 0 in the denominator of something. and division by 0 is undefined, so the slope is undefined. Okay? And they have equations that say x equals a number. So I ran into this acronym when I was teaching the very first time in graduate school, and I thought it was quite clever as a way to remember the difference between the two. Because students do, in fact, get confused between 0 slope and undefined slope quite a lot. 0 is not undefined and undefined is not 0. Okay? And also get confused about which one's x equals and which one's y equal. That's also a point of confusion. So this isn't obviously the only way to remember it, but it is a way to remember it. Okay.
Can you review the definition of a real number?
Yeah.
It's very specific, and I just want to...
Yeah, so and the reason it's going to say real number here is because we're working in a real number coordinate plane. Okay? So real numbers are decimals, fractions, all that kind of stuff, and it includes your irrationals, so you can have square roots and so forth.
Okay.
So it's easier to define what it's not than to define what it is. It's not imaginary, so you don't have any i's, like square roots of negative numbers. You don't have any complex numbers where it combines the square roots of negatives with other things. So real numbers, for the most part, are the ones that you see anytime you have all the information before about pre-calculus. Pre-calculus is usually where somebody introduces the idea of square root of -1. And that's actually called an imaginary number. It's not real, which is terrible, terrible descriptions for the two, but yeah, okay? Is that good? All right. Any other question about horizontal or vertical lines or the definitions we've used so far? Okay. So we're going to talk about equations in general. In general, lines that are not vertical have equations that can be written in the form y = mx plus b. This is called the slope-intercept equation of a line. And the reason is because you can see the slope right here, it's m, and the y-intercept right here, which is the y value of b. M stands for the slope, steepness, and direction. Direction is indicated by it being positive or negative. Steepness indicated by the size. Bigger numbers, whether they're positive or negative, actually large numbers indicate a steeper slope. Smaller numbers like 1/2 or 0.2, they're going to be a very shallow slope. It is, and we're going to do more with slope here in just a second, further on the paper down below. Yep. B stands for the y-intercept, but whenever we're actually finding a y-intercept, I do want you to understand that it's just the y-coordinate of the y-intercept. The x-coordinate is 0. So a y-intercept is actually an ordered pair point, 0b. Okay, but the b in the equation is what's identifying that. And then a linear equation is any equation that can be put into the form y = mx plus b or x = a. So we have to include the horizontal or the vertical line in there as well. Any idea why I don't need to write down y equals a number? And why don't I have to write that option down? Nope.
It could be like
Say that a little bit louder, Brianna.
It's in the y = mx plus b.
Right. What would m have to be for that to work? 0. So if m is 0, I already get y = b, right? It's just a very specific case of the y = mx plus b form. So I don't need an extra condition. But there's no way to do that with the x equals equation. It has to be defined as a separate portion of what we're looking at for lines. Okay, so very specifically, I already mentioned this, but a y-intercept is a point with coordinates 0b. It tells us how many units above, if b is positive, or below, if b is negative, the origin, that our graph will cross the y-axis. And then the x-intercept is a point with coordinates a0 that indicate where the graph crosses the x-axis. If a is positive, it will cross the x-axis on the right. If a is negative, it will cross the x-axis on the left. We've got a picture coming up for both of these ideas too. And then Hannah just asked us a minute ago about slope, so let's talk about slope. Slopes are the rate of change of y values in relation to corresponding x values. We think of it like this. A positive slope, we always read a graph just like we read English from left to right, okay? So if we're reading the graph, a positive slope is what we think of as being uphill. A negative slope is what we think of as being downhill. A zero slope is usually what we think of as being flat. And then a no slope is vertical. Like a building. Like if you were going to climb up the side of the building, I'm not advising that, but that would be vertical. There's my picture. Okay. All right, so slopes that are farther from zero, so bigger numbers bigger numbers, either positive or negative, are farther from horizontal or steeper. They're steeper. And then parallel lines have the same slope. And the exception is to vertical lines because they would have two undefined slopes. So you could say they're the same, but it's weird to say that something's the same when it just doesn't exist for each of them, right? That's what undefined kind of means. So your image here actually shows 3 parallel lines. Some different things you might notice about this particular picture. Let's start with the top one, the one that's in blue. It has a y-intercept of 2, right? Crosses to the y-axis at 2. The black one has a y-intercept of 0. And the red one has a y-intercept of -2. And then if you look at the x-intercepts, on the blue one it has an x-intercept of -2. Interestingly enough, the black one actually has an x-intercept that's also at 0. And then the red one has an x-intercept that's at 2. Okay? Also, if you look at the equations, whoops, just a second here. If you look at the equations up here, you'll notice the number at the end is different, but their value, that doesn't even look like it's there in front of x, all match. It's a number 1. So they all do, in fact, have a 1 here, and that number is the slope. So all of their slopes match. Okay, so they're parallel. So how do we go about finding slope when we're not looking at the equation? Well, the slope is, this one was what Hannah had mentioned before, it's the change in y values divided by the change in x values. Or you can think of it as the vertical change divided by the horizontal change. Or you can think of it as rise over run. Those are all different but equal or equivalent definitions for slope. Given 2 points, A is x1, y1 and B is x2, y2. The slope m of AB is y2 minus y1 over x2 minus x1, as long as x1 and x2 aren't the same. So what would happen if x1 and x2 were the same numerically to our slope? What would happen inside of this expression? We get a 0 in the denominator, which is undefined, right? So what kind of a line would that tell us that we have? Vertical. That's a vertical line. And the picture is fantastic on this too. You can see the rise, you can see the run, you can see where the y2 minus y1 comes from for the rise, the x2 minus x1 for the run, and you've got your A and your B coordinates there. And we see right triangles, don't we? Just like with Pythagoras. Okay, so we mentioned parallel lines. We're going to talk next about perpendicular lines. Did everybody get everything on this slide? There was a little more writing here than the last one. Yeah? Okay. Perpendicular lines, 2 non-vertical lines whose slopes m1 and m2 multiply to give you -1. Those are perpendicular. In other words, the slopes of perpendicular lines are negative reciprocals of one another. So, it may have been a while since you've worked with perpendicular lines. If I gave you the slope 3/4, what is the reciprocal of 3/4? Yeah, the reciprocal is 4/3, and in order to give you a perpendicular line, you'll need it to be the negative reciprocal, so it becomes negative 3/4. Notice I did not put equals in between there, right? Okay, equals does not mean, and the next part of my problem is. Sometimes we get sloppy and we do that, so don't do that for me, but arrows are certainly fine. What if I had the number 5? What would the reciprocal of 5 be? 1/5, and then it would be negative, not because it's a reciprocal, but because the perpendicular slope would be negative. And if you'll notice, what this means from the first part of their definition is if you take these two numbers and you multiply them together, what is 3/4 times negative 4/3? -1. And that's actually the definition, is that the two slopes multiply to give you -1. And they do, in fact, do that if they are negative reciprocals of one another. All right, so what we're going to do next is we're going to be given some descriptions about lines, and we're going to create a line that has certain properties. So our first one says that we're going to find an equation of a line through the point -4, 2 that is perpendicular to the line y equals 2x plus 1. And I'm going to show you and remind you a couple of different ways to actually do this. The first thing I'd like for us to do, though, is to recognize what is the slope of the line that we're given. It's 2. Okay? So this is the number that's my slope. So what would the slope of the line I'm trying to find, my perpendicular, this is how we write perpendicular, right? What would the perpendicular slope actually be? -1/2. So this is what we need. We need that -1/2. And we have the point -4, 2. If we have a point and we have a slope, we can find an equation. And I'm going to show you two ways to do it. Okay? The first way I'm going to show you is using the information I've given you so far. And the only equation of a line I've given you so far was y equals mx plus b. Agreed? Okay. I can use this information because I have a y value, I have an m value, and I have an x value, and I can use that to find b. That's one way to do it. So the y value I'm given is 2. The m value that I found was -1/2. The x value that I was given was -4. And I'm going to solve this to find b. So what is -1/2 times -4? It's 2. So what would b have to equal? 0. Okay, now we're not done because there's no equation written down yet. But we know now the b value. So we are given this equation for a line. I know the slope. The slope is -1/2. The b value is 0, or you could just not write it. But y and x are not the 2 and the -4 that they were originally when I did the problem. Okay, that was one specific point, but aren't there infinitely many points along the line? Yeah, I just used that one point to find the b value, and once I found it, when I write my equation, I leave it with x and y in there generally. You don't really need the, this is the plus 0. You don't really need the plus 0 on the end. I'm going to leave it there for the moment just to remind you we did find it, but you certainly wouldn't have to have it written. Now, there's another way that you can do this, and it depends a lot on the kind of textbooks that you're using at this level of math. Does anybody know where you learn about lines for the first time? Usually pre-algebra. So it's usually in 7th grade or 8th, depending on what level the kids are at. But there are also some 6th grade books that will encounter some of it at the first time too. So just kind of to give you a heads up of where this is falling curriculum-wise. There is another form of a line that looks like this. Do you guys remember this one? Do you remember what it's called? Point slope. Very good. And the reason it's called point slope is because here's the point, x1, y1, and here's the slope. So this is the point slope form for the line. The nice thing about this, well, the bad thing about this first, is that it's just another equation to memorize. So in some sense, there is this sort of overabundance of equations going on. I mean, we've already got an equation for slope, and we had an equation for the y-intercept form, and now I've got a third equation. So that's sort of the negative. The positive for this is that I can find the equation all at one time instead of 2 steps. In the last process, I had to find b first, and then I found the equation of the line. Okay, so if I use this form of the line, I can use the point that I was given. What was the ordered pair point I was given for y? Yeah, and that was the 2, right? Now, the minus here is because there was a minus in the form of the equation, right? That red is terrible. I need to do something different. How about yellow? That's better. So the negative staying there because of that. My m value, I had decided was -1/2. Here's my x value, and then technically what I have is minus a -4. And what is minus a negative? Plus. So if you want to jump the gun and not even write the minus and negative and just write this down as x plus 4, that's cool with me. Technically, this is an answer to the question, right? It says find the equation. Well, this is the equation. It's not in a very pretty form, but it is the equation. Okay? For the most part, unless you're told otherwise that you're going to be okay with leaving it here, I would like for you to solve it for y and simplify and clean things up. Okay? So we're going to get this to be looking like the actual equation we got on the other one when we're done. Y equals mx plus b. So I've got y minus 2 on the left. What do I do with the negative 1/2 and the x plus 4? Distribute. Very good. So on the first part, I will have negative 1/2 x. And then on the second part, I will have minus 2, because 1/2 of 4 is 2. One of them is positive, one of them is a negative. And then we want y alone, so we're going to add the 2 that's on the left as a negative 2 to the right, which leaves me with y on the left and negative 1/2 x on the right. If you want to write down a plus 0, that's fine, or you can leave it off.
How is point slope different than y2, no, x2 minus x1 over y2? Is that?
It's the same. Okay, so what you're remembering is the equation for slope.
Okay.
So if you think about the equation for slope, I'm glad that you noticed that. It's y2 minus y1 over x2 minus x1. And in fact, if I, instead of writing slope, I wrote m equals. Let me try that. Notice if I multiplied the x2 minus x1 to the other side,
It's the same.
it'd be the same equation, except that in place of where I have the x2 and the y2, I just have x's and y's written down. So it is just another version of the slope equation formula. Exactly. Okay, let's try another one. This one starts out a little different. We have 2 points given to us this time. Suppose that the points negative 1, 6, and 7, 0 are on a line. Find, first, the slope of the line. Now here's the cool thing. You can call this one x1, y1, and this one x2, y2. Or you could do it the other direction, and it will still work. Because you need to keep the subtractions in the same order from numerator to denominator, but they can switch as long as you switch them both. Okay? So what would I do for slope if I've got mine written as the x1, y1 is the negative 1, 6, and the x2, y2 is the 7, 0? 0 minus 6 over 7 minus negative 1. And if you want to write down 7 plus 1, that's fine. Please write down the slope for me. Don't just give me the answer. Because you give me the answer and you've made some silly mistake, like instead of writing down 0 minus 6, you did it in your head and you did it too fast and you got something silly like 12. I can give you partial credit if I know that that was in your head that was the problem and not the actual conceptual process. You know what I mean? Show me your work, please. So 0 minus 6 on top gives me negative 6. 7 plus 1 on bottom gives me 8. And what will this reduce to? Negative 3/4. So that's my slope in reduced simplified form. And then it says the equation of the line. So when we're working with an equation of a line and we're given 2 points, we only need to pick one of them. And it doesn't matter which one you pick, but come on, let's pick the one that's going to be easier to work with, right? And which one's going to be easier to work with? The one that's got a 0 in it is one of the 2 ordered pairs, right? So let's use the easier one just for our own sake. So we're going to use the slope of negative 3/4, and we're going to use the point of 7, 0. And which form of this do you want to do? Do you want to do the one where we start with y equal mx plus b? Or do you want to start with the y minus y1? Okay, we got a bit of both going on. So if you want to do, I'll do y equals mx plus b because Alyssa was the loudest one, and I heard her. And that's what she said. So we'll do that one. If you don't like that one and you use the other one, do that, and we'll just make sure that we both have the same answers when we're done. Sound good? Okay. So if I use y equal mx plus b, my y value that I'm given is 0. My x value, oh, I didn't get my mx plus b. It's just m plus b. Let me fix that. Better. My m value is negative 3/4. My x value is 7, and then I need to find b. Okay, so what is negative 3/4 times 7? Negative 21 over 4 plus b. So what will b equal? 21 over 4. So then my equation, y equals my slope was -3/4 times the value of x plus the b value we just got, which is 21/4. Any questions in that one? Okay. Looking at what our next page looks like, what I'd like to do is finish 3 and 4, which puts us at finishing up single equations. And that way we start next time with systems of equations, which is where we compare two equations to one another. So that's a very natural stopping spot. So let's get these last two finished up. This one says to put the equation 3x plus 2y equals 8 in slope-intercept form. Identify the slope, the y-intercept, find the x-intercept, and draw the graph of the line. Oh my goodness. Well, we'll see. Maybe we won't get all of this done in one time. This one asked me for like 6 parts or something. Okay. Putting it into a y-intercept form then, if you will, I'll call that part A. We have 3x plus 2y equals 8. What's my first step? Get the y by itself. So I'll move my 3x. This is 2y equals -3x plus 8. And then what do I do? Divide both sides by 2, or you can think of it as dividing each individual term by 2, which is really nice here because I get the -3/2 x, but then 8 divided by 2 is 4. So this is the part A of this, the slope-intercept form. Part B says to identify the slope and the y-intercept. So what is the slope? The slope is -3/2. Oops. And the y-intercept? You're missing something.
0.
Where do I put it?
0.
And 0 and then 4. Yeah. So it's an ordered pair, 0, 4. Okay? Please be careful on this. If you just write down for me that the slope is 4, the problem is that 4 is a number, whereas 0, 4 is a point. And if you put y equals 4, that's a line, right? So write the notation so it indicates what you really mean. It's the ordered pair 0, 4. All right, so that was C, if you will, the y-intercept. D says the x-intercept. Okay, so it's not directly visible in the form that we're given, so let me actually show you what we can do to find the x-intercept. Okay, so the y-intercept, as we wrote it on the last step, has the location where x is equal 0, right? So what can you tell me about the x-intercept? It's where y equals 0. So put a note to yourself, this is where y equals 0. And then wherever it is you want to put it in as y equals 0, go back to one of the equations or one of the forms of your equation and put in y equals 0. I kind of like the first one. So if I put in 3x plus 2 times 0 equals 8, then I can solve this for x. I have 3x equals 8. So what does x equal? X equals 8/3. So then, what is my x-intercept? 8/3, 0. If I stop before that, it's not written as an intercept. It's written in a line format or an equation format, okay? All right, here's the cool thing. You have so much information by finding all this stuff at this point that drawing the graph for it is super simple. So we're going to do a graph for this. So we'll draw our XY coordinate system. Oh, I probably should use a lighter color. It'd be easier to see on this backdrop. How about that one? And one way is to plot the y-intercept here, the 4 value, and then use the slope after that. So you can totally do that. But I'd like to show you another way that people sometimes don't think of. I'm going to move this down just a little bit. Is we're going to plot the 4, 1, 2, 3, 4. That's right here. And then the other thing that we already just found, like the very last step, is we found the x-intercept, right? It's at 8/3, 0. So this is 1, this is 2, and this is 3, and 8/3 is 2 2/3. It's between 2 and 3. So my x-intercept looks something like this. So I could also plot the x-intercept, the y-intercept, and connect those points. You don't have to do it that way, but it is another option. I know this doesn't look right. I'm going to move it. Now it will. Pretty close. Okay? And if you measure down 3 and over 2, does it work? I think it's pretty close. Down 3 and over 2, that's pretty close to what I said it was from my pink line, right? So either method will give you approximately the same picture given the level of accuracy you have when you're drawing. We have time for the last one because it's faster. You guys ready? All right, number 4. Find the equation for the line containing 3, 5 that is perpendicular to the y-axis. So we can think and reason through this if you'd like, but I'm kind of a fan of how about we draw the picture that it's already describing, and then the thinking and the reasoning will be much faster. Sound good? Okay, it's talking about a graph where I need to be perpendicular to the y-axis. So which one of those is the y-axis? The vertical one or the horizontal one? Lee is right. It is the vertical one. This is my y-axis. So if I'm going to be perpendicular to the y-axis, what kind of a line am I going to create? Horizontal. So this phrasing right here tells me that I'm going to have a horizontal line. Now it also tells me that I'm supposed to be going through the ordered pair 3, 5, which probably means that my picture needs to be moved down a little bit. So I need to be, and now that I'm not on one of my corners, that's better. I need to be at 3, 5. So let me extend, you know what, not even going to do that. Technology's fantastic. Problem is that when you go to actually writing things down on paper after using the technology, it's tough, isn't it? All right, 3, 5. So here's 1, 2, 3. 1, 2, 3, 4, 5. The ordered pair that we're given is this point right here. Did I get it right? Yeah, 3 and then 5. Sorry, it's a mess up there too, isn't it? Okay, so now I need to draw a horizontal line through that point. So we can draw it. Now, technically, we haven't actually done any of the parts the question asked us for, but we've got a picture to help us to give it the answer at this point. It says that we need the equation of that line. And Amy, you told me what it was. What's the equation of that line? It's y equal 5. Why? There's several ways to describe it. Why do you say it is?
Well, I mean, from the beginning, you see that the point 3, 5, you see that y is 5, and that has to be horizontal. That's the only.
So it has to go through that particular point, and every point along that line has that same y value, doesn't it? So that would be one reason for the y equal 5. Occasionally I have people who switch the x and the y in their mind. If that's you, that Hoivux thing we did at the beginning might be helpful. Horizontal lines have 0 slopes with equations, y equals, and that's what we got on this one, okay? Alrighty, we'll stop there for today.